Several manufacturers offer 4-inch square boxes designed for concrete pour applications. These include Cooper Industries with model number BR4S, Thomas & Betts with model number PFB4-4X4, Panasonic with model number WVLC 40240SA, and Siemens with model number FF4S4024. It is generally not recommended to use cast iron or stamped steel boxes for concrete pour applications, even if they are not specifically listed for use in curing concrete. There are several reasons for this recommendation. Firstly, corrosion. Cast iron and stamped steel are susceptible to corrosion. This corrosion can weaken the box and ultimately compromise the integrity of the electrical installation. Secondly, thermal expansion. Cast iron and stamped steel have different thermal expansion coefficients than concrete. This difference can lead to movement and damage as temperatures change. Thirdly, cracking. The weight of the concrete itself can put considerable pressure on the box. This pressure can cause the box to crack or deform over time. For concrete pour applications, it is strongly recommended that you use junction boxes that are specifically designed and approved for this purpose. These boxes are typically made of non-corrosive materials. Examples of non-corrosive materials include polyvinyl chloride, acrylonitrile butadiene styrene, or fiberglass. Furthermore, these specialized boxes often incorporate features that prevent cracking or movement during and after the concrete pouring process. When selecting a box for concrete pours, prioritize those explicitly designed and listed for that application. These boxes are engineered to withstand the harsh conditions associated with concrete and ensure a long-lasting, safe electrical installation. Always consult local electrical codes and regulations for specific requirements regarding electrical installations in concrete structures. Proper installation techniques are crucial. Follow the manufacturer's instructions carefully to ensure that the box is properly embedded in the concrete and that all connections are secure. Consider the environment in which the concrete structure will be located. If the structure is exposed to harsh weather conditions or corrosive elements, it is even more important to use a box that is specifically designed to withstand these conditions. Regular inspection of the electrical boxes and connections is recommended, particularly in areas where the concrete is exposed to moisture or other potentially damaging elements. Any signs of corrosion, cracking, or other damage should be addressed promptly to prevent electrical hazard. When working with concrete and electrical systems, always follow proper safety procedures. Wear appropriate personal protective equipment, such as gloves and eye protection, and ensure that the power is turned off before making any electrical connections. In addition to the box itself, consider the type of conduit and fittings that will be used to connect the box to the electrical system. Use conduit and fittings that are also approved for use in concrete and that are compatible with the box material. When pouring concrete around electrical boxes, take care to avoid damaging the box or conduit. Use appropriate techniques to consolidate the concrete and prevent air pockets from forming around the box. After the concrete has cured, inspect the installation carefully to ensure that the box is properly embedded and that all connections are secure. Before energizing the electrical system, test all circuits to ensure that they are properly grounded and that there are no shorts or other electrical faults. It is important to understand the different types of concrete and their properties. Some types of concrete may be more corrosive than others, and some may expand and contract more than others. Choose electrical boxes and components that are compatible with this specific type of concrete being used. Consider using a concrete sealant or coating to protect the electrical boxes and conduits from corrosion. These sealants can help to extend the life of the electrical system and prevent costly repairs. Regularly inspect the concrete around the electrical boxes for cracks or other signs of damage. If any damage is found, repair it promptly to prevent moisture from entering the concrete and corroding the electrical components. Consider using a ground fault circuit interrupter, or GFCI, to protect the electrical circuits in the concrete structure. A GFCI will trip the circuit if it detects a ground fault, which can help to prevent electrical shock. It is important to properly train electricians and other workers who will be installing and maintaining electrical systems in concrete structures. They should be familiar with the specific requirements for these types of installations and should be able to identify and address potential problems. Stay up to date on the latest codes and regulations for electrical installations in concrete structures. These codes and regulations are constantly evolving, so it is important to stay informed of the latest changes. Consult with a qualified electrical engineer or inspector to ensure that your electrical installation meets all applicable codes and regulations. This can help to prevent costly errors and ensure the safety of the installation. When planning an electrical installation in a concrete structure, consider the long-term maintenance requirements. Make sure that the electrical boxes and components are easily accessible for inspection and repair. It is also important to keep accurate records of the electrical installation, including the location of all boxes, conduits, and other components. This information can be helpful for future maintenance and repairs. Using the correct type of box for concrete pours ensures safety, code compliance, and longevity of the electrical system. Remember to always consult with qualified professionals for specific project needs. By understanding the potential problems associated with using the wrong type of box and the benefits of using the right type, you can make informed decisions about your electrical installations. Selecting the right materials and following proper installation techniques will ensure the safety and reliability of your electrical system for years to come. The long-term performance of electrical installations in concrete relies heavily on selecting components designed for such environments. Ignoring these recommendations can lead to premature failures, costly repairs, and potential safety hazards. Always prioritize products specifically listed and tested for direct concrete embedment. Consider the overall design and layout of the electrical system within the concrete structure. Plan for future expansion and ensure that there is adequate space for additional boxes, conduits, and other components. Use appropriate supports and harness to secure the electrical boxes and conduits to the concrete structure. This will help to prevent movement and damage over time. When running conduit through concrete, be sure to seal the ends of the conduit to prevent moisture from entering. Moisture can corrode the wires and other electrical components inside the conduit. Consider using a concrete vibrator to consolidate the concrete around the electrical boxes and conduits. This will help to eliminate air pockets and ensure that the concrete is properly bonded to the electrical component. After the concrete has cured, inspect the installation carefully for any signs of damage. If any damage is found, repair it promptly to prevent further deterioration. Establish a regular maintenance schedule for the electrical system in the concrete structure. This will help to identify and address potential problems before they become major issues. Keep detailed records of all maintenance and repairs performed on the electrical system. This information can be helpful for future troubleshooting and planning. In addition to corrosion, thermal expansion, and cracking, there are other factors to consider when selecting electrical boxes for concrete pours. These factors include the load-bearing capacity of the box, its resistance to water and chemicals, and its ability to withstand vibration and impact. Choose boxes that are specifically designed to meet the requirements of the application. Consider using a non-shrink grout to fill the space between the electrical box and the concrete. This will help to prevent movement and cracking. When installing electrical boxes in concrete walls, be sure to align them properly with the finished surface of the wall. This will ensure that the boxes are flush with the wall and that the cover plates fit properly. Use a level to ensure that the electrical boxes are installed straight and plumb. This will help to prevent problems with the wiring and other components. When connecting wires to electrical boxes in concrete, be sure to use connectors that are approved for use in concrete. These connectors will help to prevent corrosion and ensure a secure connection. Avoid using sharp objects to pry open electrical boxes in concrete. This can damage the box and create a safety hazard. If you need to remove an electrical box from concrete, use a hammer and chisel to carefully break away the concrete around the box. Be careful not to damage the box or the surrounding concrete. When replacing an electrical box in concrete, be sure to use a box that is the same size and shape as the original box. This will ensure that the cover plate fits properly and that the wiring is compatible. Dispose of old electrical boxes properly. Do not simply throw them away. Take them to a recycling center or other appropriate disposal facility. When working with concrete, always wear appropriate personal protective equipment such as gloves, eye protection, and a dust mask. Concrete dust can be harmful to your lungs and skin. Avoid getting concrete dust in your eyes or mouth. If you do, rinse them immediately with water. If you experience any irritation or other health problems after working with concrete, consult a doctor. Be aware of the potential hazards of working with electricity. Electricity can be deadly if not handled properly. Always follow proper safety procedures when working with electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. When planning an electrical installation in a concrete structure, consider the potential for future changes or additions. Make sure that the electrical system is flexible enough to accommodate these changes. Use conduit and wiring that is sized appropriately for the anticipated load. Provide extra space in the electrical boxes for future wiring. Consider using a modular electrical system that can be easily expanded or reconfigured. When selecting electrical boxes for concrete pours, consider the aesthetics of the finished installation. Choose boxes that are compatible with the overall design of the concrete structure. Use cover plates that are the same color and finish as the concrete. Consider using recessed electrical boxes that are flush with the surface of the concrete. When installing electrical boxes in exposed concrete, be sure to protect them from damage during construction. Cover the boxes with plastic or other protective material. Avoid using abrasive cleaners on the electrical boxes. These cleaners can damage the finish and make the boxes more susceptible to corrosion. Regularly inspect the electrical boxes for signs of wear and tear. Replace any damaged or worn boxes immediately. By following these tips, you can ensure that your electrical installation in concrete is safe, reliable, and aesthetically pleasing. Remember that selecting the appropriate materials, following proper installation techniques, and adhering to all applicable codes and regulations are crucial for a successful outcome.